is it going to do there? If y'all are having trouble accessing your graphs for the acceleration lab, which hopefully everybody found the email from the Average Speed Lab. If you go to your email and search for Average Speed Lab, there's an email from Google Forms that has your responses in it if you're having trouble. I'm going to just talk about the graphs at the end. If you can't find your graphs from there, because you may have been able to find your responses, but you can't access your graphs. We had problems just now. So I'm just going to, so we can make new graphs without going to a whole lot of trouble, I'm going to describe the marble's motion here. So let's see. It's always important. They can't even see me right now. It's always important to have your axes labeled with the values and the units that you're doing. I can't write over there. So like I've got that one, distance in meters over time in seconds. This one's velocity in meters over time in seconds. Or versus. And this one's acceleration in meters per second squared over time in seconds. So let me show you all how your graph should have looked. And we'll see who got it right. And if you have trouble accessing your graphs, then you can just write these down. Don't worry, this isn't going to affect your grade. We're just working on the graphs, and that's what's important. Whether you got the graphs right or wrong. I just want you to see it. So this is a distance graph. We got three different ways this graph can look. It can look like three different ways in general. It can look like this, or I don't know about this marker. Or it can look like this. Or it can look like this. I mean, I don't know about that, but there. So we've got to figure out what our marble did and how it actually should look. I know they can't see me, but they can see the graph, so it's fine. So we know our marble started at 0 meters and 0 seconds. So we know it starts from down there. All my lines started from down there except for that one. So when we, oh no, now it's on the video, dang. When we were rolling the marble, it started at 0 before we started to roll it. That was one of those lab questions I'm trying to get you to figure out. And then it started going slow. And then over the second, half a second, whatever you had, it was rolling, it sped up and it was going fast by the time it got to the bottom of your ramp or whatever you had. So a line like this, like let's say that this is 3 meters that it's at. Ours started at 0, so we know this line is wrong anyway. But even if it had started at 3, it would have gone on to 4 and 5 because it was moving. This is a line that shows that it's not moving. If it's a 3, and then it's a 3, and then it's still a 3, and then it's still a 3, that's like, you know, if it's on your meter stick here, I'm going to use this so that you can see it better. If it's on your meter stick here and it starts here, well, if it starts at 3 and it just stays there the whole time, it's not rolling this way, it's not rolling this way, it's just staying right at 3. So this is something that's not moving. So we know ours isn't like that. So we were just saying that ours sped up. Well, this line goes up. A lot of people look at this and be like, it goes up, we're done. But let's think about it. Let's write some seconds down here, I guess. 1, 2, 3, 4. So, okay. At 0 meters, it was at 0 seconds. After 1 second, it'd gone 1 meter. After 2 seconds, it'd gone 2 meters. After 3 seconds, well, I guess that's around 4 now. I tried to draw it straight, but it's increasing by about the same amount per second. You know, 1, 1, 1 point something. So this sort of line shows that it's going at a constant speed. If you have, excuse me, a straight line on a distance graph, it shows it's going at a constant speed. Yeah. So whether that was this line, that's a straight line, it was a constant speed of 0. This was a constant positive speed. Our marble, this is what it looks like when it's going slow, and then it speeds up. This is what our marble looked like, because first, after the first half second, well, after the first second, it hadn't gone very far because it's still going slow. After the next second, it sped up. It had gone all the way to 1 meter in that rest of that second. And in between 2 and 3 seconds, it went a whole meter. You'll see how this shows it speeding up. I won't talk about the next couple of graphs so much, but so a velocity graph, we aren't going to see any curved velocity graphs in here because that just makes it too complicated. The only graphs that'll be curved like that are the distance graph, and that's only when something is speeding up. You listen over there? When it's at a constant speed, the distance graph will be straight. The velocity graph will always be either flat or straight. The curve's not an option for this one. I mean, it's possible in reality, but it just makes it too complicated to calculate with. It's not useful. So our marble sped up. That's what makes the velocity graph a little simpler, because we know it started at 0 meters per second. It wasn't moving before we released it, and then it sped up. So our velocity graph is just going to look about like that. Your graph will go with your numbers. I don't have numbers. I just know your graph should be a straight line like that. And your acceleration graph, we're never going to have anything on the acceleration graph except for a flat line. So this shows that the speed was increasing, and we could look at how much it's increasing per second. Y'all are calculating this on this lab, but it's going to increase at that same amount the whole time. So like, let's say that yours increased at 1 meter per second every second. Its acceleration would be 1 meter per second the whole time. We're not going to have increasing acceleration in here. It's not ever going to go up on the acceleration graph because that just makes it too complicated. Acceleration can increase, but we don't need to do that.